All right, for this bell work, how many different possible outcomes are there if you flip a coin 3 times? So you got 3 coins. So I'll just label them 1, 2, and 3. And since they are coins, you either have heads or tails from any of the 3 coins. So that tells us that there's only 2 possible outcomes for any of the 3 coins. So if we use the fundamental counting principle on these instead of using some kind of tree diagram, which you could do to find all the results, you'd have heads or tails from the first coin, heads or tails from the second coin, and then heads or tails from the third coin. I think one of the common mistakes we may see on this, while we're getting used to the fundamental counting principle, is that students may add these together. But the fundamental counting principle does not include addition, it only includes multiplication. So if we multiply these together, we would see that there are 8 possible outcomes. And yeah, if it asked for the actual 8 outcomes, then maybe we would create a tree diagram here. But since it's only asking for how many there are, all we need to know is that there are 8. So here's our objective for the day. I can determine experimental, or they're also known as simple probabilities. So take 15 seconds and copy that down, please. So we've seen this slide before, I think during the first lesson of this unit. And the main difference between experimental and theoretical probabilities is that experimental means it's based off of something that has already happened. So on the bell work, when we were looking at how many outcomes there are with tossing 3 coins, that is theoretical because we didn't actually toss any coins. And you could say, well, there's 8 outcomes because of the theoretical probability of the way it's set up, tossing 3 coins. If we actually started tossing a coin, let's say 100 times, then we would have some experimental evidence to go off of. And then we can make our future predictions based on those experimental values that we have acquired from actually tossing those coins. Of course, you could use surveys, studies, or questionnaires for these. And yet, when you have dice or cards or maybe spinning something, yes, there are those theoretical probabilities to start out with, but once you start to spin or do whatever game it is you're playing, then things generally become more experimental. Of course, you can always have theoretical and then compare them with the experimental results, which then may help you to make perhaps even better decisions based on the 2 forms of information there. So today's objective is based on the experimental probabilities. And we're going to be using fractions like we see there at the bottom. Now you can use fundamental counting principle to find the total possibilities or results. But really, we're just going to use those experimental values in order to figure out the totals and then the probabilities themselves. So we should have both values when we're looking at the problems in today's assignment and in today's classwork. So you own a small business selling bagels. You know that in the last week, 78 customers paid cash, 18 customers used a debit card, and 118 customers used a credit card. Based on the results, express the probability that your next customer will pay with a debit card as a fraction in simplest form. So there's a couple of things we got to acknowledge it for our probability here. Of course, it will be a fraction, and that's okay. I think for me, I'd probably start with the total possible results. Or possibilities, I guess. Now, you could say that there's 3 possibilities. They could pay with cash, debit card, or credit card, but that would be more theoretical if we were doing it that way. What we have to do here is figure out how many customers have paid with these three forms of payment. So I guess I'll start with cash. Then we'll use that, look at debit cards, and then credit cards. Okay, so cash, we can see that there were 78 people that paid with cash, 18 with a debit card, and then 118 with a credit card. So all I'm going to do is take these and add them together to see how many total customers have gone through. On my calculator, I got 78 plus 18 plus 118. And when I push enter, this will tell me how many total customers paid, I guess, for bagels. That's 214. Right there. Now again, this is my total possibility, so there's 214 customers that actually did come through this business that sells bagels. Okay, well that's good. We now know the denominator, but what about the numerator? The numerator is based off of debit cards. And we know that debit cards, there were 18 customers that paid with debit cards as seen in the problem. So how often does someone pay with a debit card? Well, there were 18 customers out of the 214. All right, now this is a fraction and that's great. But what we would like is for this to be a simplified fraction, and it is simplifiable because in the ones place value we have two even numbers. So I just put this in the calculator with the N over D button, and the calculator does simplify this for me as 9 over 107. Okay, now if you wanted to change that to a decimal, just push the double arrow button right above enter, and you could see that as a decimal would come out as 0.08. 411,215, which is about 8.4%. I know it didn't ask for those last two, but in case it does in the future, we need to know how to do that, just like we did 2 lessons ago. This next problem. In a popular online role-playing game, players can create detailed designs for their characters' costumes or appearance. You set up a website where players can buy and sell these costumes online. Information about the number of people who visited your website and the number of costumes purchased in a single day is listed below. So 40 visitors purchased no costume. 82 visitors purchased exactly 1 costume. And then 6 visitors purchased more than 1 costume. Based on these results, express the probability that the next person will purchase more than 1 costume as a decimal to the nearest hundredth. Of course, we're going to start with our fraction. That's the way we're looking at probability to start with. But again, for our fraction, we are missing the denominator, the total number of people that have gone through, I guess, this online shop. So we will figure out that total just by taking the number of visitors here on the left and just adding those together. This will tell us how many total people, looks like, visited your website. So 40 plus 82 plus 6. Use a calculator if you want. Don't use one if you don't want. I don't really care. You just need to get the correct answer. Here's 128 people. So that will be our denominator for our probability, 128. All right, so 128 people visited your website. And then it asks, what's the probability, and again, this would be an experimental probability, that the next person will purchase more than 1 costume? Well, there were 6 people. 6 visitors purchased more than 1 costume, so that would be our numerator here. Now, you could simplify this fraction here, but they did ask for the answer as a decimal to the nearest hundredth. So I'm just going to type in 6 divided by 128. I'm not using the N over D button here. I'm using the division button instead of the fraction line button. And it tells me 0.046875. Okay, well that looks pretty good, except they said to round this to the nearest hundredth, which is the 4, the place value of the 4. So I looked immediately to its right and I see the 6. The 6 is 5 or more, so the 4 in that hundredth place value, I have to add 1 there, which makes this 0.05. And that'll be our answer. Of course, if they asked for the percentage, you would move the decimal 2 place values to the right, and you would get 5%. But they didn't, so we can just keep this as 0.05 as a decimal, but it still is the same thing as 5%. Of course, that's after the rounding. Here you recorded the grade level and instrument of everyone in the middle school rock band below. We got 7th and 8th graders. Based on these results, express the probability that a 7th grader chosen at random will play the guitar as a percent to the nearest whole number. So again, we'll look at this as a probability. And we'll start with the fraction, I guess. But it does say that it wants the answer changed to a percent eventually. You guys try this one out. Take 1 minute, try it out, then we'll go over it. So the first thing I'd look at on this one is that they are asking for 7th graders only, which means we don't actually even need the 8th grade numbers, which is, it's possible that it could be a mistake that students would use the 8th grade stuff, and depending on how the problem was worded, you could. But in the way this one's worded, we are not going to be using the 8th grade numbers. So, for our fraction, because we'll start with the fraction, we do need the total number of 7th graders. So, I'm gonna add these together and just figure out how many total 7th graders I guess are in this band. So 2 plus 8 plus 3 plus 5, looks like it's 18. And again, that's going to be my denominator for my fraction for my probability. All right, that looks pretty good. And then it said they're going to be chosen at random. How many of these are going to, or the probability you're going to play the guitar or find a guitar player. There we go. Well, it looks like there's 2 students that are in 7th grade in the rock band that play guitar. So that's going to be 2 out of 18. Of course, we do want the percentage here. So I'm going to type in 2 divided by 18 in my calculator. Okay, so this reads right now 2, and I'm using the division button, not the N over D button. Here, and even before I push enter, I'm going to push that second button. Because remember, I'm trying to get this to be percent. So I push second, and I want the calculator to change this to a percent, so I'm pushing the closed parentheses button. It's just one button above 9. And now if I push enter, the calculator will change this into a percentage for me. Of course, it's showing the decimal, which isn't a big deal. Right now it's showing 11 point, a lot of ones repeating. But it is also showing the percent symbol, which is pretty good. But now we got to look here and say, well, we wanted this rounded to the nearest whole number. Well, that'd be the 1 in the 1's place value. And since the place value to the right, the 10th place value is 1, it's less than 5, which means all I'm going to do is make these phantom zeros. So it appears that the probability, at least for this rock band here, that if you were to choose one of the band players randomly, and the chances that you would choose a guitar player randomly would be about 11%. At least if we rounded the nearest whole number. That's it right there. Well, there's our objective again. I can determine experimental probabilities. And these are simple because we're only looking at one situation at a time. If by chance they were like, well, you got to choose one thing and then choose another new thing, then it would change these probabilities just a little bit, but we're going to save that for next year.